Okay, so let me start with this simple algorithm. So basically, instead of using entire files of baskets, we pick up a random subset from the baskets and just assume that it is assume that particular basket as the entire database. Sorry, data set. Sorry. So the safest way to pick up the sample is to read the entire data set, and then which is for each basket. Select a particular basket for the sample, and then of course since we are picking up randomly, we fix a probability, let's say p for it, and suppose there are m baskets in the entire file. At the end we shall have a sample whose size is quite close to the product, which is p into m baskets. So for example, if the support threshold for the full dataset is S and we choose a sample of 1% of the baskets, then we may examine the sample for the item sets that appear in at least S by 100 of the baskets. So that is basically the simple algorithm. And an extension of the simple algorithm is the SON and the Toivonen algorithm. Let me start with the SON algorithm. So SON algorithm has two passes, the pass 1 and pass 2. The pass 1 has a lot of processing, as you can see. So the first pass of the SON algorithm performs the simple algorithm, to be precise. It performs the simple algorithm on the subsets that compose the partitions of the data set, and then it processes the subsets in parallel so that there is more efficiency. So these are steps in the SON. Pass 1 starting with scanning data, and then it breaks the data into chunks that can be processed in the main memory, and then it continuously fills the memory with new batch of data, and then runs the sampling algorithm on each batch of the data, and then at last it generates candidate frequent sets. So and then move on to which is the pass 2. Pass 2 takes the output of pass 1 into consideration. That is where it counts the output from the first pass and determines if an item set is frequent across all the subsets. And also it validates the candidate item sets and also counts all the candidate item sets to determine which are frequent in the entire set. And of course, an important concept which is used in SON is the monotonicity, which is an item set X is frequent overall, means that it is frequent in at least one batch. And then let me go to the Toivonen's algorithm, which is also an extension of the simple algorithm. Basically, it starts just like the simple algorithm, but in this case, there is a lower support threshold. The main goal is to prevent false negatives and also ensure that the item sets are frequent. If an item has a support that is close to the support threshold, but it's not equal to or much greater than the threshold, then it's considered frequent in the algorithm. So let me introduce you to the negative border, which I can define as when a set is not frequent in a sample, but its immediate subsets are frequent, then the main sample is said to be frequent. For example, here is the main sample ABCD is not frequent, but the subsets, which are ABC, ABD, ACD, and BCD, are frequent. Then, of course, because of that, ABCD becomes frequent. So, why I'm telling you is that an item set is in the negative order if it is not deemed frequent in the sample, but all of its immediate subsets are. So, in the second pass of the Toivonen's algorithm, counts all the frequent item sets from the first pass, which is a similar step to the pass 2 of SON, and then it also counts the frequent item sets and the negative borders. So if there's a negative border, as the frequent item set, then you have to start all over with a different support threshold value. So, my question for you is, what are the advantages of SON algorithm? SON or simple algorithm? Anything?
Just go back to the previous slide.
You require a much smaller size of your data set to pick out your rules than you would otherwise.
Yeah. Thank you. Now we move to